Swayam Prabha. Digital India. Educated India.
Dear students, we are now in the module 7 of the course Fire Safety in Buildings. So, in the previous modules we have discussed or we have seen how the different attempts are taken to inbuilt or ingrain the fire safety measures within a building, like the dry riser or the wet riser. Also we have learnt about the various standards and norms, what are to be maintained, distance between staircases, width of staircase for the evacuation process, which was the last module. Also we had understood the devastations that can happen not only from fire, but also from smoke. Today we will move to our next module, which is containing the building features and the spread of smoke and fire, how we can contain that, and also the site planning for access, because we have to give access to the fire tender finally into the site to control the fire, because whatever system is there in the building will only be operational when some people come for rescue or some people are trained in that way to operate certain mechanisms. So, already as I told, we will have all the systems in place. However, how the fire tender will come inside and help in the rescue is important, and what are the building features that can be designed through our design, we can check the spread of smoke and fire. Now, so first is to prevent my internal spread of fire. So, for that we had already discussed, but now we will be very specific. We have looked into the concept of fire compartmentation or fire cells. You can see here it is the fire compartmentation or the fire cells with the appropriate barriers. So, barriers will be with the particular materials which will be fire rated. These are to be taken from the standards, and the materials may be 2 hour rated, 1 hour rated, even half an hour rated, because there are various kinds of spaces and various qualities or requirements of space for which the fire rating has to be maintained. So, we have to look into this aspect to increase the time available for the escape, limit the area of possible loss, because through compartmentation or through application of materials and keeping only the fire within that compartment, we can limit the possibilities of the loss. Reducing the fire impact on the structure. Our structure is, we are not entering into the structural fire, but yes, steel, concrete, all are over time susceptible to fire. Concrete has a much higher retaining rate, higher time of sustaining fire. However, the overall structural system should not get damaged because of a fire outbreak. Separating different occupancies. So, a building may be in use by different occupants. Now, we have not entered into the multi-storied houses where there may be lower part may be offices, upper part may be hotel. So, it is a different occupancy. It is an assembly building in some part, and on top it may be residential occupation. So, the occupancy of the space can be differentiated by using a fire compartment. So, we can actually through this internal spread control, we can isolate the hazards and protect the escape routes. We have already talked on the escape routes, which are actually the horizontal paths as well as the vertical paths. To prevent structural collapse, as I discussed, like we have to reduce the fire impact on the structure. Structure, both load bearing and other elements which may be non load bearing, may act as a separator between two spaces, and we have to look into the stability of it. so that the whole building, entire building does not collapse. So, structural collapse is to be prevented and to reduce the probability of fire spread to other buildings. That is again another part what we had earlier discussed, that through conduction, through convection and through radiation, like conduction, convection and radiation, the fire can move, the temperature can move from one space to the other. So, if we can reduce the radiation part, or if we can check the fire within the envelope, it should not be able to destroy the fire in a neighboring building. So, that is also to be considered. Now, coming to the site conditions, we have to look into where the building is. Detailed plan and arrangement of the pump. We had talked about the pump which will allow the water through the dry riser or even to the through the wet riser. The control room from where all the switches, pumps are to be accessed. Staircase locations to be with the firefighting people. Width of the staircase, distance between the staircases, they are also to be known, because the firemen will be moving for the evacuation process. Static water and the storage pump, static water storage and the pump location are to be known to the firefighting people. Fire lifts, if any, I have discussed on fire lifts, which is a dedicated lift and a staircase and a lobby, which together is called the fire lift, should be in place if it is already, if it is allowed or sanctioned. Smoke ventilation arrangements, this also had been discussed in my fourth module. So, smoke ventilation arrangement plan, if at all any mechanical smoke venting is there, the access to those points are to be known for the fire fighting purposes. Also, we had discussed and learned how to design the sprinkler system. The entire arrangement plan of the sprinkler system has to be known for fire fighting. Now, there may be in-house people, there may be access to the firefighters to come and take the charge of extinguishing the fire or controlling the fire. So, with this checklist they start moving, and this is what I was talking about, the conduction, convection and radiation. This is a slide, I think this is a repeat slide also. So, you can see through radiation from one building to the next building, the heat is transferred and gradually the outer membrane of the building, outer material of the building is catching the fire from the radiant heat, So, that is what is radiation. So, one building catching fire to the next. This is of concern when within a site you may have two buildings, So, if one building, this part is on fire, the other building can take fire. Now, there are mandates of this gap between the two buildings, but however, there can be some leakages, there can be some breakages and the fire can move to the next building. So, to check the fire, we talked about compartmentation, we talk to retain it within the room or the origin. So, the material which is on fire, we have already discussed in the very first two modules, the heat release rate of the material is very important. So, what is burning? What is the rate of heat being released by the material? And that is how you can assess whether you can keep the fire within its room or origin. Now, initial fire spread can be flame flame impingement or radiant heat transfer from one burning item to the another. So, within a room itself the fire can grow if it can touch or reach by its radiant heat or by some flames touching the next material. So, gradually the fire spreads, but remember the flashover. Until the flashover is reached, the fire is moving, fire is still under control and the evacuation process is on. But then we need to look into whether there are vertical and horizontal possibilities of this fire spread, because if the fire leaks out from one room or one compartment through the vertical or the horizontal spaces, that is either the corridors or the staircases, then the control will be difficult. It will spread from one level to another level. We have to look into the materials which are on the walls, that is the room is lined with combustible materials or not. Say if it is a wallpaper, if it is a flammable coating, if it is a curtain, then the fire spread can be very rapid. If it is a ignitable paint, so the fire can move or propagate very fast. So, early fire hazard properties are the material ignitability, heat release, flame spread and the amount of smoke produced. As smoke, we have considered smoke as a totally separate module, you can understand other than fire the more vulnerable part or the people who are not in direct contact with the fire, but even can get smoke choked and may lead to health problems or even lead to deaths. So, we have to look if there are internally wood based material, plastic, synthetic material. Wood is safer than plastics or synthetics. However, if you have gypsum plasters, that is very good. If you have gypsum boards on the false ceiling, that is also fire resistant for some time. So, what are we doing? We are trying to contain within the room of origin by appropriate material selection within the space. So, if your ceiling, like the room where I am sitting, the ceiling is made of gypsum board. So, in case of any fire, the gypsum board will shield the fire or keep the fire within this particular room. So, we have to try to keep our fire, if at all, within its room of origin or within the compartment where it is originating. Now, coming to how it can spread to the next doors, next rooms. It will be obviously through the door openings or window openings or any connections or maybe some ducts which connect two doors, two rooms. So, it may be for running of services, you may have continuous paths. So, those are also some of the spaces which through which the adjacent rooms can the fire or the smoke can reach the adjacent rooms. So, open doors provide path for smoke and toxic combustion products to travel from the hot upper layer of the fire room into the next room or the corridor, and these can preheat the next for leading to a fire spread. Automatic door closing arrangement. Now, in very specialized places like hospital where the patient cannot come and operate, the doors should be automatically closing. There are office areas where the doors automatically close because it is a public space, no one will take the responsibility. So, let the doors be such that it automatically closes and does not allow the smoke or the fire to go out or come in. Smoke control gaskets should prevent intumescent material around door gaps, should prevent further escape of smoke from the fire compartment. Concealed spaces, cavities may be avoided, but it is not possible for all cases, as I had shown you earlier also through pictures, that we need to conceal all cavities or plug in all cavities, so that no gaps remain and no you can avoid any kind of continuous spaces to for the smoke to run. Fire resistant walls, they are a must, because we already know NBC or the National Building Code rates the walls, the materials that are to be put for external purposes. However, for internal purposes also, if it is not an open office kind, we must use fire rated materials. Installing fire stopping materials at joints, cavities and gaps. So, mineral wool, wood block, gypsum board, metal bracket, fire resistant putty, board materials and intumescent collars and pillows and mastics are very popularly used to block joints, cavities and gaps. So, insulating duct material for internal fire movement are called fire dampers, which are collectively all other materials. They can help in handling the fire spread through ducts. As you can see in this picture, even if you see this is a continuous false ceiling, it may be made of gypsum. So, the fire is not spreading, but through some gaps the smoke is spreading to another room which may be far from that also, because there may be a possibility of a leakage in this place, and already the cavity above the false ceiling, which is not at all seen from this level, is a continuous space connecting the 3 rooms. So, these 3 rooms 1, 2 and 3 are all vulnerable, because smoke is infiltrating inside it. So, the main point is, if I could have had some barrier here, some barrier here, as I had talked about for the AC, there could have been some dampers here and that could have automatically closed. That could have stopped the smoke movement from here to the other. Now, this is a case where it is within a room there are compartments made. So, it is very difficult to provide such kind of dampers, and it is usually overlooked or not provided, but a safer design would be to provide such dampers over here also. So, controlling fire spread, it was all related to the rooms or from the compartment. Now, it is controlling fire spread to other stories. The earlier was on the horizontal level, that is room to room, next was room to corridor or the adjacent room. Now, it is the fire spread to the other stories, that means fire is moving vertically. So, the internal routes, failure of the floor ceiling assembly and through vertical concealed spaces, service ducts, shafts or staircases, of which shaft and staircase are the most popular places through which they can move. What we can do? We can put doors at points when you enter these vertical shafts, that means the staircase. So, if it is a fire escape staircase, that means if your staircase is a fire escape one, you can have a door into which the staircase is accessed, is always having a control, automatic closing control, and the people are running into the staircase and the door is always getting closed. So, this fire staircase is a fire staircase and no smoke is entering into this space. So, this door is the player who is controlling the smoke movement between the 2 stories, but in many cases we have open staircases. So, in that case the smoke, and if the staircase is just adjacent to the place of fire, even the fire can move through this staircase. So, ensuring any gaps at the junction of the floor and the exterior wall for curtain wall construction should be completely sealed with non-rigid fire stopping material to allow seismic or thermal movements. Now, this is also very important. We are talking of fire always, but our building can face thermal changes, can experience seismic shocks. So, we cannot put any rigid material to ensure that there are no stresses developed and there are no cracks in the building during its entire life, because seismic forces are also something which will not happen every day, neither fire will not happen every day, but the thermal changes will happen. So, some non-rigid fire stopping materials are popularly used, which are ceramic fiber bats, blankets, which are to be made of resistive mineral like materials, mineral or fiber bats. They can be put in like cushions. So, they have the flexibility to absorb thermal movements. However, in case of seismic or in case of fire, both retain their properties. So, we are not going for any rigid kind of stop between floors, particularly in between curtain walls. Now, curtain walls nowadays the facades have continuous walls from between two floors. It may be all glass, it may be ACPs. So, these are all allowing to give a nice elevation or a aesthetic look to the building. It is no floor slab coming out and saving the building at the periphery or at the edge. So, these kind of fillers, these kind of insulating materials which are flexible in kind or are to be placed, so that the fire does not move from one floor to the other through such joints. We have talked about the general things which are the vertical services, vertical shafts and staircases, but these are also gaps which are between curtain wall and the slab. So, if that is the curtain wall and this is the slab of one floor and this is the slab of another floor, and if there is a fire somewhere here, the fire can propagate up. So, proper material should be there, proper material plugging should be there in these zones with appropriate materials like fibers, blankets, mineral bats, so that these areas do not become vulnerable in case of a fire. Other than this, we have window sizes. We may have small windows well separated. We may have projections or chhajjas. They can also stop the prevention of fire in some cases. In some cases, we will come to such pictures, some explanations or figures after this slide. Now, coming to the staircase and the area of operation in case of fire, how far the fire tender can reach the fire to control the fire, reach with the hose to control the fire. Now, inside this box you can see the hose release there, and this can be pulled to a certain distance. I have told you it is around 40 meters, 38 to 40 meters, and from that if you draw the arches, you will find out that you can serve around 900 meter square or 930 meter square from one location. Remember, our staircases as per mandate are always on an external wall. So, you cannot make a central location and have all around 360 degree. So, you can see the areas are given in dotted line. So, this staircase fire staircase is serving this part, the other staircase is serving this part, and the third staircase at this corner is serving this part. So, it is only serving one quadrant, whereas this is having a little more spread. Now, based on this, actually the number of staircases required for a building has to be determined. As you can understand, these are very large sized floor plates. So, we are talking of commercial buildings, we are talking of office spaces, we are talking of high rise buildings, where the amount of spread of the building is quite large, the floor plate area is quite large. And you can see here through the demonstration which is taken from the National Building Code, you see that the spread is quite important in deciding how many number of staircase to be put. Now, this is having a very squarish kind of form, your building may be very elongish kind, in that case the distance between staircases becomes mandatory. So, there are norms given where you will try to put the staircases at specific distances from the edge, from between the two staircases, all are to be decided out. So, we were talking of a similar kind of situation, we were trying to I tried to draw the figure. Here you can see it is not a curtain wall, it is an opening through which fire is going out. This is again a fire, this is one type, this is another type, where also the smoke is going out. Here there is opening on the wall which may be a window. So, the fire can spread and get into this. In this case the fire is not leaking, it is a little exaggerated drawing, but if there are gaps the smoke will first go and give the clue. Though the fire has not moved from one compartment to the other compartment, is moving vertically, but the smoke is giving the clue that the whole thing is moving vertically. Here you can see in this picture, you can understand that there is a fire stop at these locations. So, which is not allowing the fire to move from one chamber or one compartment to the next compartment. So, the point is our edges where the wall and the slab is meeting, what is the type of wall, whether it is a continuous wall, whether it is a glass facade, whether there is a gap between the two, has to be ensured and to be plugged in with appropriate material. So, internal areas within building notorious for aiding the spread of fire are the through and through cavities, through and through internal linings, through contents within the building. We have already talked on all these. So, install cavity barriers to prevent spread of fire, vertical shafts, it may be lifts, it may be dumb waiters, that is lifting materials, it may be false ceiling, especially if walls do not continue above ceiling. Walls do not continue above ceiling in many office spaces. Examples: offices, open offices, you may have a false ceiling, you may have small partitions for the managers and all, but the entire above the false ceiling is continuous space. Voids, also toilets, if it is a public toilet, there may be a huge space which is named as a toilet, but there may be small outlets, small WCs or urinals, and the entire, and there may be one ladies block, one gents block, and you never know on top of it there is a void. These places are usually accompanied with some janitor space and also a duct and janitor spaces. Janitor spaces, ducts, from where some fire can lead to a passage of smoke inside the top and it can run to the neighboring spaces also. So, one has to be very careful while planning such kind of offices, open offices, toilets, means public toilet or common toilet areas which are associated to the larger space. Unsealed holes in walls and ceilings for installation of pipe works cables may remain unaddressed in plugging in. So, these are the points to be mentioned. Attic regions, attic space is the space above a sloped roof. So, this is my attic space which may be used for running washing machines of a laundry, of a hotel, and there may be electrical fires. So, these kind of spaces should never be neglected. Ducts like piping intended to run services around the building are to be closed between floors. Seismic joints, expansion joints, they are all to be sealed with appropriate fire safe materials, fire resistant materials. Openings in intermediate floors, particularly false floor, if wall do not continue below the floor void. Passage of cables from false floor to adjoining sides. So, what we learned here is cavities may be anywhere in a building. So, we cannot overlook or neglect any cavity in any form which can be a way for the smoke or the fire to propagate largely. Internal linings, as I have talked about, paints, curtains, wallpapers, they can get ignited very easily. So, internal linings of a room or the area of origin, as we started with, are to be carefully looked into, because they can they have a very quick flashover. So, they will catch fire instantaneously and the safe period will be lessened. So, that is why the internal linings in places where there are chances of fire should be taken very carefully. So, these will all lead to the passive protection of the building. Upholstery, wooden, plastic furniture, curtain, we are nowadays in the mode of using plastic furnitures inside buildings, chairs, because of their convenience, because of their cost. We in winter countries, carpets, winter states, we use carpets. We have wooden cupboards and wooden linings. Even floor linings are coming as wooden strips, wooden tiles. So, all these are vulnerable and are to be kept in mind, like their fire rating are to be looked into before they are inserted in places where there can be a chance of fire. Say a residence, there may be a kitchen where there is fire. So, the appropriate wall material, wall lining material, appropriate flooring material should be there, appropriate furniture should be there, because to avoid any case of fire, and if it happens, the fire spread should be under control. So, you can see here in this picture a little technical drawing. You can see this is the fire stopping material between the curtain wall or even the wall. It may be brick, this side wall may be a brick wall, it may be a concrete wall, it may be just a thin curtain wall or a glass wall. So, wherever my floor slab is, this gap should be plugged in, and you can see here fire stopping material is there and it is held with a steel support angle cover plate on top, so that it does not easily get exposed to the fire. So, once these are getting damaged, this will get exposed and the this is the seal and that is the inserted material. So, it will stop between floor slab and the curtain wall. In this case the picture it is showing any kind of wall, but it is appropriate mostly when it is curtain wall, or it may be a brick wall and a gap between the concrete and the brick material. So, it will be required for the fire stop. As I have talked about all pipes, all spaces, you can see here these pipes are all the vertical or all the horizontal services, all horizontal service lines, passing from space 1 to space 2. So, now all of these are sealed with appropriate mastics or materials or collars, foams. You can see here it may be foam, it may be collar, it may be sealant depending on the case. You can see here fire blocks here on the vertical wall, on the horizontal, because this route is an electrical route going down. This may be one pipeline, all are sealed appropriately. Now, hope it is getting clearer, because this is a 3-dimensional view. You can see the doors, they are all sealed with appropriate gaskets, so that one particular space is all under control. You can see cast-in devices. This is coming out with a collar there and on the floor plan. So, these all help together to check all the cavities to stop the fire move from space 1 to space 2. Also, you see this may be a partition wall, it may be a gypsum board wall, and you see below that, and even if at this joint wherever it is meeting, they are all supported with fire stop sealants. So, it is not only the pipelines and services, but even the in between wall, which may be of fire grade, but because of that gap between the two, it is a temporary partition wall, maybe it may be a temporary wall. So, all areas are checked or all leaks are proofed, so that no fire or smoke can move from one space to the other. So, coming to the fourth one, after between floors, it is fire control to adjacent buildings or to the next building. Flame contact can lead to the spread of such. As I have told, it is usually the radiation from the windows or the openings which can lead for the fire to the next building. Sometimes building height is also a concern. Say a fire is on a shorter building, shorter in height, and there is a higher building on the next. So, there may be a shorter building here and next to it there may be a higher building. So, fire from here can actually from the edge can meet the next building through the radiation. So, it cannot escape, actually the heat cannot escape because of this building. So, the next building material can reach the temperature after which the burning can start. So, also there are flaming brands, this is a new term to you all. They are splinters which are coming out from the fire, which can go and hit the next surface, the adjoining surface, and the fire can start from there. So, it is a spark that is coming from one to the next, which is moving to the next and leading to the fire to a adjacent building. So, we can see that radiation from windows or any opening, high heat flux from the windows can ignite combustible cladding materials. Now, you see these are very important. In today's context, many high rise buildings are having claddings. It may be a glass cladding, cladding means a covering. It may be ACP coatings, it may not be a rated wall. It may be another window which is kept open, through which the radiant heat can lead to fire, catch fire onto any flammable material. So, we have to be particular what building is sitting next to it. So, these flaming brands carried by the wind can cause fire spread. As I told, these are splinters which can be taken by the wind direction and lead to a fire. So, this can be controlled by restricting the use of combustible roofing materials depending on the relative height of the buildings. At least 600 millimeter difference needed to prevent fire spread. 600 millimeter is 2 feet. So, minimum there should be a gap of 2 feet, so that the splinters do not affect from one material to the other. So, you can see some pictorial representation of it. You can see these are the flaming brands, which are driven by the wind, and these are going and falling onto the roof of the next building and leading to starting a fire. You can see here a smaller building leading to radiant heat to enter through the windows of the adjoining higher height building. So, there may be or a taller building. So, there are various ways or various concerns. Even if there is a fire on this building, it is not that the building on the next are safe. So, the occupants are to be alarmed and they should also be rescued or taken out. Over time, they should also understand that they should need to take safe locations, because the next building is on fire. So, if we see, as I was talking on the facades, how it becomes vulnerable. In most urban context, we are finding facade fires happening, because facade materials are no longer the fire rated materials, in context like they are made lightweight. So, people are thinking a shift towards the aesthetic looks are demanding curtain wall kind of facades, which are light in weight, gives a different look to the building, because also reduces the weight of the building, the dead load of the building. So, facades are coming up, newer facades are coming up, the materials towards fire are not protected, and the concern is maybe one building, my building is safely designed, but the next facade fire can lead to a fire in my building. So, with my context, I have to choose my material. And if you see the number of facade fires from 1990 to 2015 to 19 is quite high. It is 20 numbers of facade fires have happened in recent past, whereas it was quite low when the building material properties were of not that order. And number of facade fires vis-a-vis countries where we do not find India at all, but you see the Arabian Emirates, that is UAE countries, had much larger facade fires, also followed by China and UK. We see here that there are changes in the bylaws very strictly, the facade fire has been looked into, the curtain wall materials are looked into, and necessary changes in the bylaws on the material context has been brought into to reduce this fire. As you know, these countries, the countries under the UAE are all in the very hot zone. So, radiant heat to next building is within a very short time, it is moving, and every other building is a high rise building. There is no escape of or any wind flow or passage of the radiant heat. So, it is accumulating and leading to fire, one leading to the next. So, the bylaws became very strict after the facade fires happening in the UAE, and now the change will be should be reflected in the graphs, in the future graphs. So, relative importance of the facade function has to be known. So, we have to optimize like accessibility, flammability, moisture ingress, weight, thickness, structural stability, thermal insulation, how much of light it is allowing, how much of sound insulation it is doing, and also the return to investment, which is the money part, because every material has its cost. So, the facade functions are to be looked into, because not all are to be like, we cannot give importance only to the aesthetic purpose or only to the structural stability, but we have to make a choice based on the safety also, and we have to look into the relative importance of the functions and then make an appropriate material selection. And you can see the flammability has to be minimum. In our context, the flammability has to be minimum, which is our key concern towards the subject we are discussing. So, we have also talked about fire stops. As I told you, within a building from floor to floor, particularly when it is a curtain wall, the fire can move quickly from the edge if there is a gap. Even from the wall getting the glass getting damaged due to fire, the fire can leapfrog. In the previous lecture, I had discussed on that. Fire can leapfrog from one floor to other floor from outside. So, the fire can move from this floor to the next floor by rupturing the glass, and it can move and further move up and rupture this floor or a open window, it can move to this. So, that is called a leapfrog fire. So, now you see these gaps are to be sealed, as we are telling. Glass should be such, they should be having sprinkler system on sides, so that the glass is always kept wet and the temperature rise is under control. So, if all the sprinkling systems are in place, if all the ratings of the pluggings are appropriate, then the fire stop should function, the fire propagation should be under control. So, you see there are various rated fire stops, T rating, F rating, L rating, W rating. Now, if you go further into the subject, you will see these are against the temperature rating. Like by definition, the rating is the measure of the time taken for a thermocouple to pass from the exposed area to the unexposed area. To reach a temperature of say 325 degree Fahrenheit will be T rating. To reach a temperature of 400 degree Fahrenheit, it will be, I think, L rating. So, such ratings are also there for materials. So, how do we measure that material? Through its rating. What kind of fire stop are you using? The technical term is its rating, and rating is actually how the thermocouple should behave, means at what temperature the unexposed side, after what time the unexposed side should get that particular temperature. So, with this you can see these are the fire stops and the gaps are to be plugged in. I have shown you in the other one also. So, this is all glass and this is all glass facade and this is the slab where it is meeting, and it may be a mullion on which the glass wall is, glass curtain wall is, and it is fastened at the various locations. We are having the fire stop material with the particular rating for your understanding. So, with this we would like to end this module, that is module 7, and from the next modules we will get into the different spaces and we will have our further discussions. Thank you.